My name is Donna Dietz. I teach mathematics and computer science at American University. And this talk is based on my experiences at University of Pennsylvania when I taught in the Computer Information Science Department. First, I'm going to give you some context, some assumptions about the students, and talk about unit testing and how it's useful in a discrete course, and what is precompiled code and why I feel it's useful in a course, and give an example. I've taught discrete in a variety of places, but particularly the context at Penn is I had entirely master's degree students, and they were not expected to have any programming background. I would say roughly half of them had programming background. But they were all concurrently taking an Intro to Programming course. Now that's not necessary, but of course it would make your life way easier if this were the case. So you could certainly run a discrete course and say must be taken concurrently with or as a prerequisite, co-requisite situation. That's certainly a workable scenario. Okay, my assumption about the students is the students should have a strong math background. It doesn't necessarily include calculus, but they should be strong in the math that they do know. And they should either have no programming background or they should be within the first year of learning, because by the time they hit that first year mark, they should be starting to write their own unit testers. And so it would be a little bit talking down to them if everybody in the class already knew how to write unit testers and you're providing them for them. I would hope the students are eager to learn, because that makes it for any other problem. If the students want to learn and they're eager to work, then that's golden. Okay. How much should you alter your course that you are already doing? This is more generic advice. I would suggest don't alter too many things at once. So when I first got into this, I decided to just get rid of all my paper homework and replace it entirely with programming projects. And the downside of that is I kept giving them exams on paper, but I discovered that the paper homework was vital to helping them prepare for the paper exams. So I would say don't completely overhaul your classroom style, regardless of what good ideas you hear here. Then I would say use them in moderation, and as you become more comfortable, expand their use. A brief overview of benefit of using this unit testing and precompiled code. Just working with students with having them program their implementations of these discrete mathematics concepts. They learn that they have to keep on going until it's right. And this is an important lesson that I think is really missing from what happens when they submit exams or paper on homework. They feel if I just clear that 90% hurdle, I get my A. And so they feel that 90% is excellent, when in fact in many situations 90% is a complete failure because it's not right. The other thing that helps the students is really conceptualize what a function is. You know, this kind of idea, right? The input-output pairing. So students often really focus on the algebraic expression and think that that is somehow intrinsically the function, as opposed to the function is the pairing of the inputs and the outputs. And using the unit tests and the precompiled code both help drive home the point of that is what a function is, that it provides this set of inputs and outputs, and the implementation is somehow hidden, and the implementation is a separate discussion. Okay, so what is a unit test? So originally it's a tool from industry, from software engineering, and it helps programmers write better code and faster. And it was originally brought into upper level computer science programming classroom in order to help prepare the CS students for programming jobs. And what happened is it very quickly became recognized as an excellent tool for beginners. And I think it's gaining more traction as a way to help jumpstart the early days of programming, even from the very, very beginning. Before it was a software engineering tool, it was just an engineering term, and the unit test could potentially destroy the product, so only a few samples would be unit tested. But of course, since software engineering is software is non-destructive, the software engineering testing should be non-destructive. So in this case, you do it as part of the building process rather than something that's done after the fact. How does it work? Well, what happens is, from your working environment where you're writing the code, maybe you're working at a command line, or maybe you're working from IDE, which is an interactive development environment, you basically just say, hey, please run the unit tests. And then it grabs the unit tests, and the unit tests calls the package that you're writing and says, okay, your functions passed or failed on these, if they pass, you don't hear much about it. If it fails, it tells you why it failed. For example, let's say you're writing a package and you want to convert Roman numerals to decimals, and you say, hey, I want, when you hand me an x, I should get a 9 back. And your function says, you give me an x, I give you a 9. And I'm like, okay, that's good. Sometimes the specification is more flexible. You may say, hey, if I give you 4 i's, you could either give me back a 4, or you could say that's invalid input. So that's kind of implementation dependent, but I can write my unit tester to be flexible enough to accept those various types of replies, and then that's okay. But let's say I want to test to make sure I does not give me back anything useful, and instead my unit test, maybe my function gives me back the number 5, and so I say, hey, you failed that test. Okay, so that's what unit testing does. What about precompiled code? Precompiled code is sort of partway between human readable code and machine runnable code. So in the bad old days of computer science, we used to kind of think of languages as being languages that you compile or languages that you interpret, where scripting language would be more interpreted languages. But it's not actually a feature of the language, it's a choice you make. And either choice can be made about any language, and there's a whole continuum of options now available to us. And what happens specifically in the case of Python is, in the case of converting this, so in the case of Python, what happens in the process of running the code, you don't actually compile and then run, you just say, hey, run this code, but it sort of creates these little mouse trails, or these little leftover pieces, and Python says, hey, I don't need to do this again twice, so the next time I run it, it'll be faster. And sometimes this pick code is generated and sometimes it's not, and it feels like a big mystery. When is it created and when is it not? When does it get erased? When does it get saved? But the important point is you can specifically ask Python to create this code. In that case, you just create it and say, hey, it's there now. Now, the wonderful thing about Python, you get rid of the original code, and guess what happens? The pick code contains everything necessary for the machine to run the code. Now, you can't alter it. It's frozen, right? You can't get in there and change anything or get rid of any bugs. It's frozen, but you can run it in the form it was when you first compiled it. Okay, so in Python, the pick code alone contains all the code content. It is not humanly readable. It is not easily reverse compiled, like, say, Java. Don't make this mistake. Don't do this in Java without really thinking about what you're getting into. Pick code allows the students to play directly with the completed project before they start writing it. What if a student says, hey, you didn't tell me what I'm supposed to do if the user gives me little lowercase letters I? Am I supposed to actually make a 3 come back or say invalid input? What am I supposed to do? And I would say, hey, I didn't say anything about that, and that wasn't part of the specifications, don't worry about it. But the student may stay up all night worrying about it. So all they have to do is say, hey, what did she do when she wrote her project? And maybe I'd come back with invalid input, maybe I'd come back with an answer. I don't know what I would do. But in any case, the student would know this is at the very least an acceptable thing to do, and so they can just proceed without worrying about it. So Python is a really great language for beginners, and it's also free. And all these things are true about MATLAB, except it being free. MATLAB is extremely expensive. So if you happen to already have access to MATLAB, great, but it's even a barrier even for students working off their own laptops. So even if you have access to MATLAB, you still may prefer to use Python just because it's so easy for the students to get a hold of and put on their own machines. Are there any other choices? Not Java, not C++, not C or C# or JavaScript, and pretty much you want Python. Okay, so what do I provide for my students? I provide them written instructions, and they technically don't need any of the code that I provide. Everything can be done directly from the written specifications that I give in the PDF. But now I've already explained to you what the unit tests are, what the complete project looks like, and then the skeleton of the project is just the completed project, but it's gutted, okay? There may be clues in there or hints, but primarily what the gutted project includes is just references back to the key. So what happens is every time you call the project, you're actually calling the key. And so then what you do is little by little, you delete all those dependencies until your project stands on its own and passes the unit tester without the presence of the key. Having the precompiled code and the unit test together acts as a 24-hour TA. It allows students to work around all sorts of problems, at least in a temporary fashion, so that if they feel completely backed up in the corner, they can just get out and then work on some other aspect of the project and then come see you with very specific questions and say, well, I could get this function and this function to work, but this one I had to use your code, so otherwise I couldn't get this other piece to work. That helps them just be very, very specific with their questions. It allows experimentation, like I said. It allows the student to find bugs even in the tester. Okay. So if you're the type of person who does not want your students to see your mistakes, then this is not the way to go because they will find every last bug in your program, just letting you know. Now I'll give you an example. First of all, I created a bug intentionally in this code by just returning some bogus value. And so what happens when I run the unit tester, of my 5 tests, 3 of them failed. So up here, you can't really see, but it says FFF ... and so that tells me that 3 tests failed and 2 passed. It does not tell me which tests passed. However, the details down here do break out each failure and explain exactly why each failure failed. Okay? So then after that, I'm just going to show you how the student can patch around this. Let's say the student has a block of code and they suspect there's an error in here. They can simply say return, and so like they use an import command to say I'm going to import the key, and I'm going to use the key and call the same function off of the key and then just return that value. So they know now that this function is working because it's just using the answer key. And then they can work on some other part of the program that depends on that. And then when they're done working on whatever else, they can come back here. And like I said, so this unit tester now worked for everything. There's 5 dots, that means everything passed. And then let's say they've cleaned up this code. You see now the import command on the key is gone, so we're not referencing the key, and there's no more calls to the key anywhere in the code, and then the unit test works. And this is what it looks like in Windows. Basically the same thing. The nice thing about this is the Windows IDE called idle, and it has some pluses and minuses. One of the nice things about it though is it's color coded, so you can see all the pieces and see what they do. And again, you have, in this case, we ran 5 tests and 1 of them failed and 4 of them passed. Okay, so you can see exactly why the test failed. So just to summarize, the unit test plus the precompiled code as a combination acts as a 24-hour TA service. It allows students to really focus on the math or the algorithmic side, and it really cuts down on the nonsense that they don't want to deal with chasing down small little typos or not being able to at least bracket where their mistakes are. The high-level development is done for the students, so really we're focusing more on whatever specific task you want them to focus on. If you want them to really think deeply about the Euclidean algorithm, that's the part they're writing, not all the infrastructure that goes along with it. So you can just give them whatever code you want and tell them, this is the code I want you to write. This algorithm I want you to think about, that's the one you're going to write up. It's really great for introductory levels of programming, as I said, and the preparation work is really vital, but it pays off huge dividends, really huge dividends, because then when the students come to you, their questions are more focused, not just like, I don't know where to begin. They actually know where to begin, they've made some progress, and they can tell you which unit test is not working for them. So that's it.